What's up guys, welcome to the steady state summary. This video is going to be a simple explanation of enzyme kinetics and interpreting the graphs associated with them. We'll also be going over the effects of inhibitors on these plots and what that might look like. Shown here is a Michaelis-Menten plot and a Line-Weaver-Burk plot. The two values most important to recognize are the Vmax and the Km. The Vmax is a hypothetical value that is technically never reached, and it represents the maximum rate enzymes can reach when they are fully saturated. The units for this value are important, and they are something that will relate to product formed over some unit of time. The Km value is a concentration value, and will typically be given in millimolar or some other concentration unit. This value is the concentration of substrate where the rate is at exactly half of Vmax. When determining these values from a Michaelis-Menten plot, the Vmax is typically an asymptotic value, meaning that because it is never reached, it will only be slightly above the maximum rate reached on the graph. By estimating this Vmax on the graph, you can use this information to find Km simply by finding the concentration where the rate is at half this value. Line-Weaver-Burk plots may initially look more complicated, but can actually be much clearer when you know how to read them. The y-intercept of the graph is equal to the inverse of Vmax, or 1 divided by Vmax. This means that the larger the Vmax value, the lower the y-intercept will be, because this value will be a smaller number. In addition, the x-intercept represents the value equal to -1 divided by Km. Because of the way the plot is set up, the larger the Km value, the closer this value will fall to the origin of the graph. This graph represents the effects of different inhibitors on the values discussed on the previous slide. The red line represents a competitive inhibitor. As you can see from this graph, this value still reaches the Vmax, but has a higher Km value than the normal enzyme. This is because a competitive inhibitor fights with the substrate for the active site of the enzyme, so a higher concentration of substrate is needed to reach the half of Vmax. This inhibitor can be overcome by adding more substrate. The non-competitive inhibitor has a different effect. This Km value is unaffected, but the Vmax is significantly lower. This is because a non-competitive inhibitor does not compete for the active site and instead binds allosterically to the enzyme to inhibit its function. Because of this, increasing the concentration of substrate won't do anything to the Km, since there is no competition for the active site. Instead, it will lower the amount of enzyme available for catalyzing a reaction, which then decreases the Vmax to a lower value than the normal enzyme. This image shows the same effects, but what to expect on a Line-Weaver-Burk plot. For the competitive inhibitor, the Km value is increased, therefore leading to a smaller value x-intercept. As you can also see, the Vmax is unaffected, and so the y-intercept is the same as the normal enzyme, shown in red. Additionally, for non-competitive inhibition, the y-intercept is a much higher value than the normal enzyme. This is because the Vmax is smaller, meaning that 1 divided by the Vmax is a higher value. The Km is left unaffected, and so the x-intercept does remain the same. If you have any questions about this video, feel free to email me or Dr. Bernstein. I hope you all are staying safe, and feel free to reach out with questions about the project as well. Stay easy.